Oh hey, I didn't see you there. I was just pondering about the 5 major mass extinctions.
Did you know that studying the 5 major mass extinctions provides insight into the environmental drivers associated with biodiversity threats and can help mitigate future biodiversity loss?
Let's move on to the main content of our video.
The 5 mass extinctions are the late Ordovician, the late Devonian, the Permian Triassic, the Triassic Jurassic, and the Cretaceous.
This is the impact of the late Ordovician. A major ice age was the cause of the 85% of marine life extinction. It had a big effect on marine life, especially those that lived in shallow waters.
Furthermore, the late Devonian was triggered by a mix of factors such as oceanic anoxia, climate change, and potentially impacts from asteroids, led to the extinction of almost 75% of marine life. Coral and trilobites, among other marine organisms, were most impacted.
Permian Triassic, often referred as the Great Dying. This was the most devastating extinction event, wiping out around 96% of marine species and 70% of terrestrial vertebrate species. It's believed to have been caused by massive volcanic eruptions, which is now Siberia, leading to global warming, ocean acidification, and anoxic conditions.
The Cretaceous was likely triggered by a massive asteroid impact. The impact caused widespread environmental devastation, including wildfires, tsunamis, and nuclear winter effect due to dust and debris ejected into the atmosphere.
The main kill mechanisms for the 5 mass extinctions were mainly volcanic eruptions or changes in the ocean. In the Cretaceous-Paleogene extinction, the main kill mechanism was an asteroid.
The name of the asteroid was the Chicxulub impactor.
A fun fact about mass extinctions is that it took place when most of life on Earth lived in seas.
Studying these 5 major mass extinctions can help us prevent future catastrophes. Scientists who study clues on mass extinctions don't only find clues about the Earth's evolution, but they also find patterns in which they can use to predict future disasters. Many scientists claim that we are now making our way towards the 6th mass extinction, as the Earth's atmosphere is experiencing similar elements that were the main factors of the past 5 mass extinctions. There are many habitats that are losing their population, and we are currently experiencing a climate crisis. Humans have emitted a vast amount of CO2 in the atmosphere, which leads us to face this problem. Ways in which you can prevent the amount of CO2 from increasing in the atmosphere is by saving energy at home and by walking or biking, considering it will reduce greenhouse gas emissions.
To summarize our findings on this topic, while theoretical models have provided valuable insights, empirical studies stress the importance of a more nuanced understanding of post-extinction dynamics. Examining these recoveries gives valuable insights into how ecosystems respond to disturbances and the mechanisms behind diversification, offering crucial lessons for advising current challenges in biodiversity conservation.
The past fossil records from the 5 major mass extinctions help researchers to examine traits and habits in which tend to lead to higher extinction risk under certain conditions. Additionally, the 5 major mass extinction events were driven by the decrease or increase of greenhouse gas emissions, which evidently still is an ongoing issue today.
According to the report, there may come a time when the carbon cycle is disrupted to the point when the cycle itself intensifies the initial disruption. This disruption is linked to both human-caused CO2 emissions and volcanic eruptions, and it may be a possible 6th major extinction event. The amount of CO2 produced overall, as opposed to only its rate of increase, determines the tipping point in the modern era.
The primary driver of mass extinction seems to come from the significant changes of the Earth's carbon cycle, which are notably through events such as large igneous province eruptions. These are huge volcanoes that are capable of floating thousands of square miles of lava. These eruptions release substantial volumes of heat-trapping gases into the atmosphere.
Well, that's enough pondering for today. I'll see you next time. Bye!